Hi, good morning A2 class. Okay, quickly going to go through the multiple choice questions in this video from the chemistry mock that you took in January. Okay, so question one, pretty straightforward as long as you know what an isotope is, although not everybody got this right, one has to say. You need to find out the atomic number of iodine and take it away from the mass number, and that'll tell you the number of neutrons. Okay, what is the bonding between the ligands and the metal ion in that complex that's given there? Always dative covalent because ligands donate a pair of electrons. That's one of their different definitions. The oxidation number of manganese in potassium manganate. Potassium is always +1, oxygen is always -2, and then the difference to get us back to 0 will be your manganese, which in this case is +6. Question 4, greatest percentage by mass of calcium. Obviously here you're just looking at the masses of all the extra bits to the calcium. That's going to give you a pretty clear idea which one will have the greatest percentage by mass, and it doesn't take the brain of Britain to work out, hopefully, that the OH being only having a relative mass of 17, your calcium is going to have the greatest percentage by mass. You can work it all out, of course, but you don't actually need to if you recognise that. Question 5 gives you some values of HCl reacting with calcium oxide, asking you what volume of HCl is required. So obviously you need to write the equation so that you know the ratio. Quickly scribble out the equation, and then you can work out your volume, number of moles over concentration. So yeah, equation, number of moles, work out your volume. How many electrons removed from 2.02 times 10 to the minus 2 grams of neon? Find out how many moles that is. Then you're going to multiply it by 6.02 times 10 to the 23. If you're multiplying, you add the indices, so 23 plus minus equals 20, so your answer is 6.02 times 10 to the 20. Okay, question 7. The mass of silicon made when you heat silicon tetrachloride with zinc. You're given a mass here, so you're obviously going to have to work out number of moles. The ratio is 1:1, you can see that from the equation, but it does say 90% yield, so that's the sting in the tail as such. You have to work out what 90% of the number of moles that you calculate is. Question 8, okay, where you need to know your chemical tests. If you don't know your chemical tests, you struggle with a question like this. The only thing you can do is guess. What forms white precipitate or chlorides do? Is there anything there that tests for a chloride, which would be nitric acid, silver nitrate? No, there isn't. But barium chloride tests for sulfate, which gives a white precipitate. So D. So educated guess if you're not sure. Number 9, you're given some enthalpy values. You're looking for the bond enthalpy of the HI bond here. Okay, so you've got these two. So these two added together minus 2 of these will give you the delta H value. Yeah. So because when you're using average bond enthalpies, remember it's the reactants minus the sum of the reactants minus the sum of the products. Okay, so the first two minus the products, which we don't know, and obviously we just rearrange for X. Number 10, I don't think anybody got this right, I'm not quite sure, maybe one. person, you've got to be careful which graph you're thinking about here. This is a concentration time graph, and so the answer is A, because it shows a constant gradient, no change in the rate. Okay. C, which a lot of you put, is a rate concentration graph. Yeah, no change in the rate. Okay. So be careful, learn those graph shapes, but also think about what they show you. You know, it's all very well learning the shapes, but recognise that it could be rate concentration or concentration time. Number 11, we're told that you've got Cr3+ ions with an excess of sodium hydroxide. So the excess of sodium hydroxide forms this particular ion. And again, you need to learn it if you don't know it. If it wasn't in excess, you could get this one. Definitely not neither of those two. Okay, HA, HB, strong acids, monobasic, and you're asked for the H+ concentration. So you need to work out your number of moles of both of them. Add the number of moles together because they're strong acids, so you know they both totally dissociate. So number of moles of HA and the number of moles of HB, they're going to release that number of hydrogen ions, and then you can work out concentration, okay, from number of moles over volume. Don't forget to add your two volumes together, that's important. Whenever you're doing a calculation with solutions, invariably like that, you would need to add the two together. Okay, so nitrogen and oxygen gases, you're given the total pressure and you're told the mole fraction of nitrogen is 0.7. So, and asked for the partial pressure of oxygen. So obviously this equation you need to know. Mole fraction of gas times total pressure, okay, equals partial pressure. So we've got the partial pressure of the nitrogen, so and the total pressure will be 1, so that gives us the mole fraction of O2, and then put that into that equation. It's pretty straightforward. But obviously if you've forgotten that equation, you'll struggle. Okay, a bit of electrochemistry. So you're given two redox systems with their cell potential and asked for the correct statement. So you can see straight away that number 1 is not correct if you recognise how to work out cell potential. Yeah. So that is not correct. So you know that anything with 1 in it, it can't be. So there you go. Only 2 and 3. Pretty straightforward. Yeah, I've said here, you know, the more positive minus the more negative. So if you quickly did that calculation, that would tell you that number 1 is not correct. Electron configurations, chromium and copper, they are exceptions, and iron isn't. So you wouldn't get this arrangement of the D5-4s1 at the end. These two. Don't forget that the chromium, you have your 5 unpaired electrons, and the 4th shell electron goes into the S1, is S1, and the same with copper, only this time you've got 5 lots of paired electrons with the full d orbitals. Those two arrangements make those atoms more stable, that's why they take up, and they are exceptions, and you need to learn them, okay? And that's the end of the MCQ questions, so not too painful, but hopefully helpful if you weren't sure why you got them wrong. Now I'll do another video showing the extended questions. Thanks.